All right. So welcome to week 2, the CAD and 3D printing course. Last week, we were talking a lot about extrudes and revolves, just kind of getting the basics of sketching down. Today, we're going to be building off that foundation to allow us to create, more complex sketches and, make them nice and robust. So, intermediate design skills. Okay, so last week, again, we were talking a lot about, sketching things and constraining things. We were mostly using the sketch dimension tool, which is just like setting one point to the other and having a distance, or like setting a length of something or an angle or a diameter. So that's all great, and that's all very important when it comes to designing things. But you don't always need to use the sketch dimension tool, right? There's a lot of things that might be implied when you design something, especially when you're creating, things that might be square or something like that. So there's a bunch of different design tools that we use to relate different parts of the sketch, other than just the sketch dimension tool, right? The other reason why you might want to use this is so you can limit those sketch dimensions, so you can focus. It allows you to focus on what's important and what's less important, right? So to do that, we use something called geometric constraints. And, there's going to be a couple of slides showing all of the ones available to you. I'm assuming most of you have taken a geometry course, so a lot of these terms are familiar to you, parallel, perpendicular, stuff like that. Concentric is a big one that you might be using a lot. It's just making sure the center of two circles are aligned or at the same point. Collinear, it's all, most of these terms have like the usage in the name, like both of the lines are on the same line. So if you have two lines and you want to connect them, collinear is good. Coincident is very important as well. It's just making sure a point is connected to another point or a line or something like that. And this works even if they're not directly connecting. So you can have a line and then have a point coincident to it, even if the line doesn't extend that far. But like if you theoretically created an infinitely long line, that point could be on there. So technically it could not be touching, but it still would be coincident. So that is something that is good to keep in mind. It's something that some people miss on the homework assignment. So yeah, that's a little hint for you. Anyways, there's a couple others, horizontal and vertical, that kind of makes sense. Tangent, we kind of used a little bit last week to make, the nice smooth transition from arcs to lines. So I personally am a big fan of tangent lines, just because it makes things nice. But, there's all these as well, like smooth, equal, symmetry. You kind of get the idea. I'm not going to go over the definition of all of them. But yeah, I'm assuming you're all in the Discord at this point, so all you have to do is download this file. We're going to open it in Fusion, and we're going to just start getting some practice with some geometric constraints. So if you go under the Resources tab, there's this Fusion file here. We're going to want to download it, and then we're going to launch Fusion. Okay, wow, this is great. Also, who didn't bring a mouse today, out of curiosity? Okay, that is okay. I forgot to bring my extra mouse, but I'll make sure to bring it next time. Do you have a mouse?
Yeah.
Okay, cool. Yeah. Oh, you have one? Okay.
Sorry, can we get one?
Oh yeah, it's in there. Okay, so now that I'm in Fusion, I'm gonna find my folder here, and then I'm gonna upload the file. Okay, so raise your hand if you're not here yet. Okay, sweet. Okay, so we have this file here. You can see there's like this image with some text on it and then a sketch. Again, this is where the timeline's useful, so you can kind of see what's going on here. You know, there's a canvas with that image. They've created a plane, and then they've created a sketch here. And one of the nice things about most parametric CAD softwares is that you can go and edit sketches and you know, features after you've made them. So I'm going to edit this sketch, right? I'm not going to make a new one because we want to modify the stuff that is given. I'm going to hide this. And now you can see, you know, we're in the sketch tools, the toolbar changes, and then there's a bunch of these red icons up here. Those are our geometric constraints, right? So, you know, there's a bunch of little problems here. They each have some kind of prompt that we just have to follow. Most of these will result in the lines being blue just because they're kind of in free space. But just keep in mind when you're actually making sketches, the general goal is to use, you know, a combination of dimensional and geometric constraints to fully constrain your sketch, right? And it, you know, again, that's making your lines and arcs either white or black, depending on if you're in like the light or the dark theme, right? So again, it's going to stay blue for most of these, but when you're actually making sketches, like we will later today, your goal is to make them fully constrained. So I'm just going to start with this one. You can see here it's asking me to make it perpendicular. There's a bunch of tools here. If you want more, you can click on the drop down. You know, here I want it perpendicular, so you can select the tool and then click on the two things that you want to apply that constraint to, and then boom, makes it perpendicular. I'm just going to do a couple of these, and then I'm going to let everyone go free to try it on their own. And then if there's any confusion, then I can address the harder ones. So, yeah. So this one says to make all these three lines parallel to each other. So what I'm going to do is I have to exit the perpendicular tool. So I usually just press escape. But you can also just click on the next one. I'm going to do it in another way, just so you know. You can actually shift click like the two things you want to apply the constraint to, and then click on the constraint you want to apply. So you can kind of do both ways, right? You can click these two after selecting or before selecting the tool. Just make sure if you want to apply a different constraint that you're not in the constraint, a different constraint tool, right? Because then you might apply a constraint that you didn't want to on accident, and sometimes they can get kind of hard to delete. So yeah. If you want to delete a constraint, Sometimes you kind of have to find it. It can be a little bit difficult to find at times, because sometimes they're like hidden and sometimes they're easier to see. In general, when I'm making my own sketches and there's a constraint somewhere that I don't really want, I find it to be easier to just kind of delete the line or the arc and then kind of start over. But, you know, depending on the scenario, your mileage may vary. You know, I'm going to hide this canvas. You can kind of see them a little bit better. I don't think you can see it on the projector very well. But there's these little, like, tiny gray icons with that constraint that we applied, right? There's a parallel constraint here. So there's these little tiny parallel icons. If I like click on them, it'll highlight the two things that are associated with it, and I can delete it by pressing like the delete key. So if you can find it, that's great, but oftentimes I might just delete and start again. I'm going to show this canvas again, the little eyeball up here, and then, you know, it has all these prompts. So I'm going to let everyone go for, I don't know, like 10, 15 minutes, and then if there's any confusion, I can help brush up on some of them, and then we can keep moving forward. So, yeah. So some people ask about this one a lot. So this is asking you to use a combination of geometric and dimensional constraints. So there's 3 circles here, you know, labeled 1, 2, and 3. It asks to dimension circle number 3 to a diameter of 2. So, you know, this little symbol with the circle and the slash through it is the diameter symbol. So you want to make this 2 inches. You want to fix circles 1 and 2, and then make the circle 3 tangent to both of them. So the process that I would go about it is I would first apply this sketch dimension. So I'm going to make this 2. And then it says to fix circles 1 and 2. I will say now, like, the fix constraint is something that we teach you, but it's not something we encourage you to use, because when you fix something, you're basically fixing something that's arbitrarily placed, right? So it's not super precise, right? Because I could drag this circle, you know, to anywhere on my screen and fix it, and it would make it technically fully constrained, but it's in an arbitrary position. So typically when you want to create a really precise sketch, you're not going to want to use this constraint. We just teach it to you so you know how to use it, but I would say for 99.9% of the time, you're not going to use it. I've only used it once over, you know, my 6 to 8 years of CAD experience, and that was because I was creating like an involute curve for like a gear, and it was like some weird complex math stuff, and that line was already equation driven, and it was just fixed afterwards. So it's a very like niche tool, so you shouldn't use it, and I will know if you use it because it will appear as a different color when you do fix something. So in this case, I'm going to fix circles 1 and 2. You can fix the outer diameter, which will also fix its position, right? So once I fix it, you can see it turns green and I can't move it. You can also fix points, right? So I could technically fix the center point of the circle and I could still change the diameter, but I'm going to fix both. Again, they both turn green, so if your sketch is open and there's green stuff, you know, obviously not this dimension, but if your lines and stuff are green, I'm going to know. So don't do that, except for this part right here. The last one says to make circles, circle 3 tangent to 1 and 2. So I'm going to use the tangent tool, and then I'm going to select these two circles, and then these two. And then you can see here, this circle turns white because these are fixed in place, and now this can't move anywhere. So, yeah. So they're like two different categories, so they go. Well, like typically, you need like to constrain space. Like two constraints. It's all very interesting. So, let's see that very complex section. But then there's because the rest of all are so if you pair both of them together, you can have a very complex section. That makes sense. There's a change, right? Because we have big dimension constraints in lost. So, yeah, so. Like, so I would dimension it to points 0. Okay. The next element is 0. That's right. Like, I mean, generally, it's like something. But it was unless it's not. But then if you're doing 2 points, like yeah, so like and we'll drive into different points, right? Okay, so I'm gonna go over the last problem in the bottom right, because this also kind of is a conceptual thing when it comes to how Fusion works. For some reason, Autodesk decided to have the vertical and horizontal constraint in the same tool. Most other CAD softwares have them separate. But because of that, whenever you make lines vertical or horizontal, Fusion will make some assumptions to try to apply the constraint in the way that you want. So basically, you maybe did like the vertical and horizontal ones here, right? And, it's going to work in this case and this case as well, right? But you can also apply the horizontal and vertical constraints to two different points, right? So in this case, I want all of these, the centers of the circle to be on the same horizontal plane. So I can be like, oh, I want this point and this point to be horizontal with each other, right? But you'll see when I apply that in this case, it'll snap to be vertical instead of horizontal, right? Obviously, I don't want that in this case. So I'm going to have to do a couple of things to kind of encourage Fusion to go the way I want it to go. So how I see it is Fusion will kind of do the easiest thing, or it'll take the path of least resistance to make whatever thing you ask it true, right? So this one, in this case, again, horizontal or vertical. So you tell Fusion, I want these 2 points to be horizontal or vertical. It's going to pick the easiest way. And in this case, these 2 points are closer to being vertical than they are to being horizontal, right? So, I did this and it's wrong, but if I kind of massage the sketch a little bit and encourage it, in this case now, I move this, it's a little bit closer to horizontal. So when I apply it, it makes them horizontal with each other. So you want to keep this in mind when you're creating your sketches. Don't hesitate to drag unconstrained things around to put them in a better position to be constrained the way you want. Because this kind of stuff happens all the time, and then you'll get really frustrated because you're like, oh, why did it go vertical? Because I wanted it to be horizontal. So that's one of the little quirks about Fusion that you might need to get used to, just kind of moving things around. But yeah, in general, it's not a bad thing to move things around manually before you constrain stuff. Again, I like to say that I like to put things kind of in the incorrect position before I apply certain constraints, just so I can visually see that I'm applying something and it's going where I want it to go, right? Like when I was talking about, drawing that rectangle the other day on this red line, I'm implying that it should be on the red line, but it's not actually constrained to that line until you apply a constraint. So my rule of thumb is to draw something away from where you want it to be, or like its final resting place, and then applying, a certain constraint to it afterwards, so you can manually confirm that it's where you want it to go, right? So, I want it to be on this line. I think the origin's here, so I can be like, oh, I want these 2 points to be horizontal. Oh, that's just a floating point. Great. Okay, here's the origin. Right, so once I manually add that constraint, you can see it turns white. So that's kind of just a practice that I've got into the habit of doing, and it might make your life a little bit easier, especially when it comes to making more complex sketches. And again, like foreshadowing on the homework, I feel like week 2's homework assignment is typically the assignment people have most challenges with. Um, just because, you know, it's a lot more complex, but the goal is for you to be able to do that, and then you'll be very proficient in making, you know, good constrained sketches, and you can like bring those practices into whatever you make. Because sketches are, you know, the foundation of all our models. So you typically want them to be really good and like readable, if that makes sense. So yeah. Does anyone have any questions? No? Okay, cool. Okay, who needs more time on this? Because you can also just finish this later. All right, so most of you seem to be done. Cool. Okay, so the next assignment is to create this gear. We're not going to be doing like involute curve stuff like I was talking about earlier. We're just going to create a very simple one here. We're going to expand our tool set, you know, using the circular pattern and whole wizard stuff. So it's going to be nice and fun. So I'm creating a new design, and then I'm going to make a new sketch. I'm selecting this top plane here, and then I'm just going to start sketching. So you can see here, this is kind of what we're after, right? If we look at this sketch, we have this circle, and then we have a bunch of gear teeth. And if you really wanted to, you could go and model or draw each gear individually. If you really wanted to, you could. But we're lazy and we only want to do it once. And the advantage of being lazy in some cases is that it'll make it easier for you later as well, at least when it comes to CADing stuff. So what we're going to do is we're going to create like a profile of this tooth. We're going to mirror it, and then we're going to pattern it around the whole circle. So I'm just going to start drawing this circle. I'm going to draw one vertical line to the edge of the circle here, and then I'm going to keep going. I'm purposely drawing it in a kind of weird fashion, just like this, just to get more practice doing constraints and stuff. So obviously this looks really whack, right? It's not anything super close to what we're after. But now that we have all the lines there, we can start constraining things and making it how we want it. So I'm going to first start by applying a diameter to this. And then for me, I'm going to just start adding geometric constraints. So this line here, I'm actually just going to delete this line because we technically don't need it. I'm going to make this line, or this point, vertical to this one, or to the origin here. I want this line to be horizontal. So again, if it was like this, it would go vertical, but I want it to be horizontal. So I'm going to kind of move it a little bit. I want this point to be coincident to the circle because I want it to be closed. Just like that. And you can kind of see this gear is taking shape here. I don't even need this technically. Okay. So now that I have this, I'm going to apply some dimensional constraints. In this case, I want to set this vertical dimension. And then I'm also going to set this angle here. So I'm going to click this line and then this line, and then I can apply this angle. And then you can see there's still some stuff that's not fully constrained, right? This line is blue, and what I like to do is to kind of drag stuff around to see how the sketch reacts to what I do. You can see here, this angle is fixed, this height is fixed, but it slides side to side. So that means I need to add another one. I'm going to add this dimensional constraint here, make it like 15 or something. And now the sketch is fully constrained, right? Does anyone raise your hand if you need more time to get to here? Okay. Oh, okay. Yeah, one thing to note, sometimes you'll be like in one of the like constraining tools when you want to drag stuff around. Just remember to hit like escape just to make sure you're in like the selection tool instead of the um, constraint tool. Because sometimes I start dragging stuff. So I use the you click on them. Well, the dimensions are fixed. Okay, everyone good here? All right, so now that we have this, what we're going to do is we're going to mirror this, right? Because gear teeth are almost always symmetrical. So there's the mirror tool right here. It looks like two triangles. One is a different color. You're gonna select these two, but then it's gonna ask you for a mirror line. I kind of deleted it, so I'm gonna remake it real quick. So I'm gonna draw a line from here to here because I want this to be mirrored across that. The other thing I'm gonna do is I'm gonna make this a construction line. Basically, what a construction line is it's a reference line that you can create in your sketches, but Fusion will ignore it when it goes to make like extrusions and stuff like that. So I'm going to make it a construction line. You can right click the line and then do normal construction, or you can press X, or you can press this button here, right? And then pressing it again will make it non-construction. But if you zoom in a little bit, the construction lines are dashed. So that's how you can differentiate them from each other or from normal lines. So I'm going to use that as the mirror line. I'm going to go into the mirror tool again. I want to copy these two across this specified mirror line. So again, selecting mirror line, clicking that line. There's a preview there. And then there. I have this lovely tooth profile here. Actually gonna make these a bit smaller. Okay. Does anyone need me to do that again? No? Okay. Yeah, that's your tooth profile, right? It's fully constrained, right? Because both of these lines are just mirrors of this. So because this is fully constrained, this is also constrained. And if I apply any changes to these lines, it will also apply it to the other lines, right? Oh, I can't go bigger. Right? So that's good. Now the next thing I'm going to do, obviously most gears don't have just one tooth. So we're going to pattern it around the circle. I'm going to create a circular pattern here. I'm going to select the whole tooth. So I can go about clicking all these lines, or you can highlight them. One thing to note is the direction that you drag your mouse into highlighting actually makes a difference on how it highlights. I didn't actually know this for quite a long time, but basically if you go in one direction, it will select everything it touches, regardless if it's fully inside or not. So if I highlight this way, you can see all these blue lines, or all these lines light up, even though like these diagonal lines aren't fully inside this yellow box I've created, right? So generally, if you select to the left, it'll do that, either up or down. But if I select to the right, it'll only select things that are fully inside the box, right? So in this case, we have that vertical construction line and then these two diagonal lines. When I let go, you'll see it only selects these two, right? So that's just kind of how it works. In this case, I want to just copy all of these. So I'm going to do a circular pattern, and then it's going to ask me to select a center point, which should be the origin in this case. You can see there's a preview, and then it'll ask you, how many teeth do you want? So I'm going to do like 5. I'm actually going to make this a bit bigger, maybe like 100. You can also edit the pattern. So at the center of where the pattern happens, there's this little pattern icon. You can double click it and edit it. Sometimes it's harder to find. But yeah, that looks a little bit more gear-like. Does this make sense? So the pattern, the pattern icon is this little icon right there. Yeah. Anyone need me to do the pattern again? Yeah. Okay, so we have this, right? We have our tooth. I'm going to create a circular pattern. I'm going to select the objects. So I want these to all be copied. I'm going to select a center point, which is the origin. And then I specify a quantity. For me, I'm doing 5. Again, you don't need to copy all my dimensions and numbers exactly. Just as long as you have the general idea of the tool and stuff like that. Yeah, everyone good here? Okay. So now that we have this, I'm going to go and extrude it. before I do that, I'm gonna just undo these construction lines just to show you what happens if you don't make things construction. So these are all solid now, and you can see as I highlight my mouse over it, there's a bunch of individual sections that I can choose from. And when I want to extrude that, that means I need to click on every single one of these to specify what I want extruded. But if I was to make these construction, you can see it greatly reduces the number of closed areas that I can highlight, right? You can see this whole circle's being highlighted now. It's not like a little slice of a pie, it's the whole thing. And each tooth is its own closed body. You can even go further by trimming away the excess of these like little arcs on the circles. So I could go like this and trim it away. And now it's one whole closed body, right? You don't have to do that, but that is an option. So this looks good to me. I'm going to finish the sketch and then I'm going to extrude it. Since I trimmed away everything, it'll select everything automatically, but you might need to go and click through all the closed bodies if you didn't. I'm just going to extrude it to like an arbitrary length. Now we have our gear. Does that make sense? Good. Okay. So the other thing about this assignment is that we want to add a threaded hole in the center of this gear. So if it was a normal hole, like your instinct might just be, oh, I'm going to make a sketch, I'm going to draw a circle, and then I'm going to extrude it negatively into the gear to have a hole, right? In this case, we want a thread, so it would be a little bit more complicated, because then you'd be like, you could extrude it, and then you'd have to draw a helix, and then like cut the helix out, which is really annoying. Or you could use the hole wizard. So a lot of CAD programs have some kind of hole tool or hole wizard, and it allows you to kind of select standardized hole sizes, or you can even make custom hole sizes. And you know, there is some benefit to using it as a designer because, you know, it saves you some time. You don't need to create like complex sketches for threads. But even when it comes to straight holes with no threads at all, there's a lot of information that the hole wizard can convey to someone manufacturing your part, right? So there's a lot of scenarios where you might design a part that you're not actually going to make yourself, and then you're going to, you know, send your design to some company or someone else that you know to make the part for you. And you want to give them as much information as you can so they don't make a mistake on the part. Because, you know, if they make a mistake, you know, it'll cost you money or the company money, and no one's going to be happy. You're just going to have a sad piece of metal or whatever material you have that wasn't to spec. So when it comes to holes, the type of hole can be very important. So using the hole wizard gives you, or gives the machinist more information than just, you know, extruding a hole. If you are extruding like a circle. So Fusion actually has a CAM tool, which allows you to program like CNC machines to make your parts. And it will use like the different feature data to kind of generate tool paths, right? So when you have a whole feature in your timeline, you know, the CAM software will read that and be like, oh, there's a hole here. So I'm going to use like a drill bit, right? Or whatever tool that you specified. But if you just have some kind of sketch and extruded cut, Fusion won't know if it's actually something that needs a drill bit or not, right? Even though it could be a circular hole, Fusion could be like, oh, that's a pocket, not a hole. So I'm going to use an end mill instead of a drill bit. And then if you do that, you know, it could take a considerable more amount of time, which makes it more expensive, or it could just be straight up wrong, right? So using the hole wizard sets your machinist up for success. So that's why it's a really good idea to use it. When I first started making parts, it's not something I really cared about because I'm like, oh, I'm just doing this for myself. I know what goes here. But when you start working with other people, you want to kind of give them as much information as you can. So I know that's a really long ramble for explaining why you want to use this tool, but I hope that makes sense. So for this, I'm just going to use the hole tool here, which is right next to revolve. In this case, I want to select a face that the hole starts from. And then I want to specify points. So I'm just going to kind of drag it here to the center. But if you wanted to make a bunch of different holes or something like that, you could also create a sketch, like add a bunch of points, and then use that as a reference for your hole tool. So I'm just doing one hole in the center for today. But you can see here, there's a bunch of different options, right? And this can be very convenient for when you're making certain parts, because you might want to countersink or counterbore. And it'll do all of this stuff in one operation while retaining more information, right? This gives you information on the depth, even the angle of the drill bit, if that's important to whatever you're making, and then obviously the diameter as well. In our case, we're going to make a tapped hole, so I'm selecting this. And then if I scroll down here, there's even more information, right? You can select different thread profiles. Oops. You can select different thread profiles, even like right hand or left hand threads. So, this is all a lot of information that it's very useful to someone machining or assembling your part. So you kind of want to give that to them. I'm just going to make this comically large. I'm going to select some random thread profile. In this case, I want this to go all the way through, so I'm going to set the distance to all, but you can do it manually if you want as well. But yeah, this looks good. So when I press OK, and I zoom in, you can see we have this thread profile. So that's what we're looking for. And this is also why I mentioned last week that the timeline is important, because you can see what tools you used, right? In this case, we started with a sketch, we made an extrusion, and then we used the hole tool. So when you submit your assignments from this week and forward, you want to make sure you have your timeline so I can see what you did, right? Here, we used the hole tool with some threads, so I'll know that you did that if I read your timeline, right? If I just made a straight hole with an extrusion, and I cut it all the way through, right? This will look different in the timeline, right? Even though, they may look similar. In this case, it's not a straight hole and it's threaded, but I will see that in the timeline. So for stuff like this, please follow along, because then you won't lose points, right? Obviously, when you make your own stuff, you can do whatever you want, but these assignments are here so you learn how to use new tools that we introduced to you. But yeah, any questions? I know I went on like a very long rant about the hole tool, but it is important. So yeah. No questions? Okay, cool. I'll be looking at time. Oh well, okay. We're going pretty quickly. All right, so for the next one, we're going to create this hair dryer, and then we're gonna approach this in kind of a different way than we've been making our other stuff. In this case, we're going to be using a loft. So if you look at this profile here, there's a couple of different ways you can make it, right? Before, if you ignore the loft tool, right, you could create this profile by using a revolve, right? You can draw this 2D profile of this hair dryer and then revolve it around the center axis, and it would create, the same effect, right? But in this case, we're going to teach you a different tool, which is called a loft. And it's pretty cool because you can, create, very simple sketches and then create a very nice, smooth, complex shape. It makes things look nice and pretty. So to do that, what we're going to do, instead of starting from a sketch, we're going to kind of build kind of a foundation for the sketches that we're about to create. You can see here in this photo, there's 4 circles, but they're actually not on the same plane, right? So whenever you make your sketches, it'll ask you to select one of these 3 planes, and that's just off the origin. But you can also create your own planes to create other geometries. So in this picture, you can see there's 2 more planes above this one, and then there's actually one more here, but I think it's hidden because there's no orange square, but it's still there. So to create a plane, there's this construct tab right here. There's a bunch of different options. I'm going to be using the offset plane along with the mid plane just to show you how they work. So I'm going to start with an offset. For this assignment, I like to offset stuff from the top plane. So it's this one right here. I can specify some distance. I'll probably just go like here. And then I'm also going to create 2 more planes on top of that. So I'm going to offset off the plane I created, but you can offset from, this plane as well. I'm going to go considerably farther. And then for the last one, I'm just going to use a mid plane. You can do 3 offset planes if you want, but I'm just doing a mid plane just to kind of show you the different tools. So for the mid plane, you select 2 different planes and then it puts it in the middle. So you should have something, looks something like this. If you rotate around, you can kind of see how all of these are stacking on top of each other. So that's kind of what we're after. Does anyone need more time? All right, cool. So the next step, is to create a bunch of circles. So I'm going to create 4 different circles of different diameters on all the planes we just created. So I'm going to create a sketch. I'm going to start at the top plane, selecting this bottom one. Maybe like 80 is good. I'm going to finish this. Again, it's fully constrained. I drew the circle at the origin, and you'll see why this is nice and convenient. Because when I create another sketch, I want all of these circles to be concentric with each other. So drawing them all at the origin will make our life easier. So I'm going to make this one a little bit bigger. I'm going to make this one smaller. Maybe I'll do like, and then the last one, and make it flare out a little bit. Okay, so you should have something that looks like this. Circles don't have to be exactly the same dimensions as mine. Okay. Who needs more time? Okay. Okay, so now that we're here, we're gonna create our loft. So I'm gonna go under create loft. And then we're gonna start selecting the profiles. So when you select your loft profiles, you wanna make sure you select them in order, or else it's gonna try to like invert itself. So, you know, don't do like, oh, I'm gonna go here, and then there, and then there, and then there. Like, it's gonna be like super weird and like inverted, right? We don't really want that. So you just wanna select them in order. And when we do that, we have this nice vase looking model here. Right. And again, you know, you could have done this by, you know, making a sketch here, like drawing a line, and then having some like combination of like circles or like arcs and stuff going all the way up, right? That's like possible. But in this case, it's like a little bit more annoying. And the loft is a little bit more straightforward for this model. It all depends on what you're going after and what you want to modify. Okay. So I have this. The next thing I'm going to do is I'm going to hollow out the inside. So you can see here, it's asking you to use the shell tool. So shell tool is right here. It'll basically create a nice constant width throughout the area you select, right? Because this is a complex shape, right? You wouldn't want to manually revolve a thin section of area, because, you know, then you're gonna have to draw a line and like offset that, and it can get quite annoying. But you can just hit shell, select a face, specify some wall thickness. So let's do like, I'm gonna make it bigger so it's easier to see, but you can make it thinner. But yeah, creates this nice wall that has a constant width throughout this body. All right, so that looks good to me. The next thing to do is to add fillets to the top of this body. I'm purposely going to do it wrong, just to show you something that I call a dependency in a little bit. But basically, what you're going to want to do is create a fillet on just the outer edge. I'm going to create it on the inner and the outer edge, which you're free to do if you want. But the correct way in this scenario is just to do the outer. But I'm going to do both. Okay. So yeah, you should have a nice rounded corner on the outside. Should be flat on the inside. Or you're welcome to follow along while I do this incorrectly. So the next thing, I'm going to create a nice little handle for this. What I like to do, instead of creating it like on the, like kind of intersecting through the face of this hairdryer, I like to make my offset plane extend beyond the body. And I'll show you why in a little bit. So I'm going to create an offset plane off one of these planes. So it's either this one or this one. I typically like picking the right plane. And then I'm going to make it extend beyond that outside surface. So it doesn't have to be a lot, just enough that it extends beyond it. I think 70 is fine. And then I'm going to start making this handle here. So I'm going to make a sketch on the plane that we just created, and then I'm going to draw a circle. And again, you can see here the origin is there. We have this nice green line running through the center. And that's because, we drew all these circles on the origin. So it kind of makes our life easier later on, right? When we want to make things kind of in relation to stuff we've already created. So I want this to be centered here, so I'm going to make it horizontal, vertical to the origin. I'm going to specify this distance. Maybe I'll do like 60. And then I'll specify this diameter. So you should have a sketch that kind of protrudes outwards, kind of in floating space here. Looks good. I'm going to finish this sketch. So yeah, raise your hand if you need more time. No? Okay. So this looks good. I'm going to extrude this into a handle. So instead of extruding it with just one direction as one side, I'm going to set it to two sides instead. So there's two arrows. Side 1 is just going to go straight out into space. I'll do like 200. But side 2, I want to go into the hairdryer, right? Right now I just dragged it arbitrarily, so Fusion thinks I want to cut into it, but I don't want that. What I'm going to do, instead of making it a distance extrusion, I'm going to make it a two object extrusion. So what it's going to do is going to let me select this hairdryer body we created before, and if I click on the outer surface, it'll kind of morph the extrusion around without creating any excess extrusion on this side, right? It just extrudes up to this face. So that's what I want. The operation's set to join because I want these two to, become one body. This looks good to me. And I'm going to confirm it. Looks good. You can see, if you look inside the hairdryer, I can't talk today. The inside is still very smooth. There's no excess extrusion coming out of it. Just kind of what we're looking for here. So that looks good. I'm also going to apply a chamfer on the end of this. So yeah, we have this nice hairdryer body. Raise your hand if you need more time. You can chill for a second. All right. So everyone should be about here, right? Everyone's good. So now I'm going to talk a little bit about dependencies in your model. Again, we're kind of talking and like highlighting the timeline a little bit more in week 2 because the way you go about designing things and the order in which you do things can heavily affect the outcome of your model. So one of the things that you can do in your timeline is you can move certain operations around, right? And because the reason why they call it a timeline is it's almost like a story of how you made your part, right? You know, you first start with these planes, you make sketches, extrudes, and stuff like that. But you can kind of rearrange the different operations to kind of change your timeline or change your story, and you might get a different part out of it. So in this case, we have this kind of hairdryer looking thing. This area is hollow, but let's just say I also wanted this area to be hollow as well, because, we want to put electronics or whatever inside, right? I could, cut something out, make another sketch, but in this case, I could also just utilize the shell tool or the shell feature that we created to shell not only the kind of hairdryer head, but also the handle at the same time. So to do that, you can change where this operation starts. So, this operation was created here, but then you did a bunch of stuff afterwards, right? That didn't exist beforehand. So you would want this to happen after you made all these things for it to hollow out both the head and the handle at the same time. The thing you need to keep in mind is there's some features that I've created here that are dependent on other features to exist, right? So because I did this like quote unquote improperly, the fillet feature I created here is dependent on the shell feature to exist, right? Because I not only added a fillet on this side, but also on the inner edge, which wouldn't exist unless the shell was made there, right? So if I want to move this shell to happen after I've created this, I kind of need to remove some obstacles or dependencies that I've created along the way. So in this case, this fillet can't be here without this shell. So I'm going to have to remove that. So I'm going to edit this fillet. Or actually, before I do that, I'm going to show you, you can drag stuff around in your timeline, but you can see if I try to drag this shell, my mouse is all the way to the right beyond everything, but there's that white vertical line that's stopping right at the fillet, right? And it's because the fillet is dependent on it. So to remove dependency, I'm going to get rid of this right here. So if you hold down Control, it'll allow you to select the line or deselect it. So I'm going to deselect that line and only make a fillet on the outside. And then I'm going to move the shell all the way to the front. And you can see now that I've removed the dependency, I can move the shell all the way to the front. And if we look closely inside, this area is now hollow as well. And again, if you look at your timeline, the number of operations or features is the same, but you've reordered it in a way that produces a different model. So that can be a very powerful tool, but you need to make sure that if you want to move something, you need to make sure that it's not, or other features aren't dependent on it existing. Sometimes if you have certain operations in certain orders, it will result in something like this, right? I created the shell before the chamfer, so it makes it nice all the way up to there. But then if I add the chamfer afterwards, there's like this floating area here. But if I change the order, that goes away. And then this is nice and smooth on the inside. Does that make sense? And obviously this doesn't just apply to shells, but it applies to every single feature that you create. So it's a very powerful tool. I guess on a side note, typically when I design things, I add my chamfers and fillets at the end, because in general, like, they're kind of like a cleanup, like end of part kind of thing to make it look nice and pretty. But I would say for a majority of the features that you create, you don't need a fillet there to create your part. And, you know, when I want to make more clean timelines, I like doing like one big fillet at the end where it fillets everything. So if I do the fillet at the end instead of like as I go, then I won't make dependencies, right? Because if I fillet this, technically like the outer edge that we filleted away doesn't exist anymore. And it's usually easier to just create dimensions and sketches off like a clean face like this instead of something with, you know, more extra features that technically aren't necessary, right? Like if I made a sketch now on the top, I could technically constrain it to here and it would be exactly the same, or it would be basically the same as if I did it to there without the fillet. But then if I modify the fillet, then it changes all of these references going forward, right? So to me, it's good practice to just kind of put like your dress up features at the end. That's just kind of a side note. Does that make sense? Yeah? Okay. The last thing we want to do here is add a little wire at the end of this. So what we're going to do is we're going to use the tool called the sweep tool. It functions kind of similarly to a loft in the sense that you're going to create multiple 2D sketches to make, you know, a 3D profile. But instead of, you know, stacking circles or whatever here, we're going to create a path for it to follow and then a profile. In this case, the profile is just a simple circle. Okay. So I'm going to make two sketches. My first sketch is going to be on this face. Make a circle here. I want this circle to be centered on here, so I'm going to make this concentric. I'm going to add a dimension here. Looks good. And then I'm going to make another sketch which kind of represents the path the wire is going to take. So I'm going to make a sketch. I'm going to choose this plane here, which is the front plane. And this is another reason why you kind of like, it's a good idea to base your sketches off the origin, just because it'll make a nice clean cut through certain things, right? In this case, this plane goes straight through the middle of this hairdryer, which is kind of what we want. If you drew, you know, your circle way over here, then you'd have to create more planes, and that's just kind of a pain. So again, you can do things off the origin, but sometimes it's a lot easier to not do that. Okay, so we have this. We want to create a line that goes off the center of this circle here. Because I made this sketch here, there's kind of a nice convenient point. But I'm just going to assume that I don't have that in this case, just to show you another tool. So I'm going to hide this. You can use geometry that exists in your model and bring it into your sketch. So that method is called projecting. So you can project something onto a 2D sketch that already exists. In this case, I want to project this circle. So I'm going to press P, which is the shortcut for projecting. And then I'm going to select the edge of this circle. So it selects this. When I confirm it, I'm going to hide this. You can see it creates a nice vertical line on our sketch here, right? And it's because, if you look at the hairdryer from the perspective of the plane that we're drawing it from, that circle just looks like a line, right? And because it's a line now, it has a nice midpoint that we can build off of. So I'm going to draw a line off the midpoint, and then I'm going to use the fit point spline tool just to make it look a little bit more organic. Just going to click a couple places. I'm going to press OK. To make a nice smooth transition from the line to the spline, I'm going to add a tangent constraint between the line and the spline. See, it looks good there. I'm going to, smooth this out a little bit. But yeah, this looks good to me. I'm not really going to bother constraining this just because it's kind of organic. What I will do is I'm going to convert this into a construction line so Fusion knows not to reference it. So I'm going to convert this projected line into a construction line that is also projected. An advantage of using projected lines or arcs is that if that line or reference changes, your model will, or the rest of this stuff connected to it will also go with it, right? Because you could say, let's say the diameter of this is 10, and you could like measure from the bottom of here to there is 5. But, if this changes to like 15 or 20, then this may not be centered anymore, right? But if you project it and then go off something like a midpoint, it's always geometrically going to be centered on this circle. So that's nice. So this looks good to me. I'm going to confirm it. And then I'm going to create a sweep. It'll ask me for two things, the profile and the path. So the profile in this case is the circle that we created, just here, not that, here. And then the path is that line we have. So if we click on that, you should get this nice looking wire here. Does that make sense? Does anybody need me to go over this again? Yeah.
Like just over the part that needs to find
Defining like this line. Okay. So I made a sketch on this plane. Again, if you look on it from the top, the plane is here, right? So it cuts through the center of the hairdryer. So I'm going to use that. I want it to go off this face. So I'm going to reference it with a projection by pressing P, selecting that line, pressing OK. You can see here it kind of snaps to the midpoint with that triangular icon. I'm going to make a line and then a fit point spline. And then when the spline's finished, you just hit the check mark. And then you make these two tangent with each other here. So it has a nice transition. And then the last thing I did is I set this as construction just to reduce any confusion to Fusion. So it doesn't think to, sweep it along this vertical line. And then do the sweep, create sweep. You select the profile, which is that circle we made, and then the path is just that line and spline combination we made. Yeah. Any other questions? Again, this is recorded, so if you ever need to reference this later, I'll post it to YouTube. Nothing? All right, cool. All right, so we have about 10 minutes left in class, so I think we're going to get out a little bit early. I'm just going to spend a little bit of time explaining the homework assignment, again, because I think it's probably the more difficult ones, or one of the more difficult ones in this class. But basically, your goal is to replicate this extrusion here. So this is an aluminum extrusion profile. It's a pretty standard profile that is very common when you build certain things. So on week 5, I'm going to bring my 3D printer into class for a demo, and you'll see that it's made of aluminum extrusions that look very similar to this. So people like to use it for a bunch of different things. People make like desks out of this. But, you know, the main advantage is, you know, they're all the same, or they're kind of standardized, and they have these little profiles that you can insert hardware into. So there's something called a T-nut that will fit in here, and then you can add like nuts and bolts into it. So, you know, you can add accessories or whatever you want to your aluminum extrusion. So it's great for prototyping if you're ever making stuff. This stuff's really popular. Anyways, you can see here, there's a couple dimensions on it, even though this looks like a very complex sketch, which it is, right? But if you use geometric and dimensional constraints properly, you shouldn't have to have more than what's on the screen. In this case, it's actually missing some stuff. So when you are doing your homework assignment, you want to reference this sketch right here. I've added a couple extra dimensions to make it a little bit easier. But you shouldn't have anything more than this. And you also shouldn't have any duplicates, right? So if you have any duplicates, that means that you can set two things equal to each other with the equal constraint instead of using, you know, two of the same number, right? And essentially, you want to keep the dimensional constraint count to a minimum, or it should be exactly what is on this screen right now, right? If you have more than the number of these, then you're going to lose points. Like, all of these little radii are all the same. So, you know, hint, hint, you shouldn't have like 0.1 3 times. You can have 0.1 once, and then you can set them all equal to each other, right? Also here is kind of like a preview on how I did it. You can see here, there are these kind of dashed lines. This was made in another program called SolidWorks, but it's essentially the same thing, right? Here I have construction lines, and I use that as kind of a foundation to the rest of my sketch, right? So I made this kind of construction square with these two diagonals, and then I use that to constrain the rest of the sketch. You can see all of these lines are what we're going after. And similar to the gear problem or assignment, I only modeled part of the profile, right? And then after you fully constrain this, you can mirror it, you know, across this line, and then you can pattern the whole thing. Hint, hint. Please do that, because that's the easiest way to do it, in my opinion. I would recommend you fully constrain your partial profile before you mirror stuff, because once you have, you know, a bunch of mirrored components and patterned components, every change you make is going to make your computer cry. And, you know, it's a lot easier to do it when there's less stuff on the screen. So before you mirror and pattern stuff, it should look like this. Oops. But yeah, in the end, your profile should look like this. So you should screenshot this. Make sure you screenshot your sketch open, right? Because I want to see all the dimensions and the constraints you used. If you exit the sketch, I'm just going to see a profile, and sometimes it's blue, sometimes it's not, right? This is basically purely a sketching assignment, right? So I want you to master your sketches, so I want to see it. So if I see anything blue or anything green, like I'm going to know that something's, unconstrained or fixed. So avoid that. But yeah, that's kind of what I'm looking for this assignment. Again, if you have any questions or you need clarification, or if you want extra help, feel free to reach out. I mean, I am a little bit busy this week because I have 2 midterms, but I will do my best to get back to you. You also have TAs, right? And you also have a week to do this. So I'm sure I'll find some amount of time after exams to respond to people if they have questions. But yeah, that's basically it for today. I hope this information is helpful to you when you approach your homework assignment this week. But yeah, other than that, that's all I have for this week. Guess I'll see you next week. And yeah, thank you.